This is a presentation of Chapter 2, Section 7 in the 7th grade note guide entitled Greatest Common Factor. And our objective here today is to be able to find the greatest common factor of two or more whole numbers. So let's give this a definition to start. What is greatest common factor? Greatest common factor, that's the greatest whole number that divides evenly into two or more numbers. The greatest whole number that divides evenly into two or more numbers. So an important place to start then would be to make sure we know what a factor is. Factors are two numbers that multiply together to make a given number. For instance, if we were looking at the number 6, the factors of 6 would be 1 and 6, because 1 times 6 is 6, and 2 and 3, because 2 times 3 makes 6. Those are factors. So you're going to generate, in one possibility here, generate a list of factors for a given set of numbers, and then do the same thing for another list of numbers, and then you're going to identify the largest number that's on both lists. And that's how we'll identify the greatest common factor. Now, the reason I say one possibility is that technique works great if you have generally smaller numbers to work with. If you have larger numbers to work with, though, that really could take a long time, and there's another method that we can use to find the greatest common factor when we have those bigger numbers to deal with, which is something you'll see in the presentation here today. Okay, so let's look at number 1 here. They're asking us to find the greatest common factor of 12, 36, and 54. So they started exactly as I said. They're going to go ahead and list factors of each of those numbers. So for 12, they went through and found the numbers that multiply together to make that number. 1 and 12, because 1 times 12 is 12. 2 and 6, because 2 times 6 is 12. And 3 and 4, because 3 times 4 is 12. All right, 36 list is a little bit long, but it's not really all that difficult because it is a small number. 1 and 36, 2 and 18, 3 and 12, 4 and 9, and of course 6 with itself, because 6 times 6 makes 36. And then for 54, 1 and 54, 2 and 27, 3 and 18, and 6 and 9. Of course, all those pairs there multiply together to make 54. Okay, so you've got lists of factors now. So now we can find the greatest common factor. The greatest common factor is the biggest number that's on all three of the lists. So if we head down the 12 list here, since it's the shortest, we see 12. And 12 is indeed on the first and the second list. But the problem is it's got to be on all three of the lists here. And 12 is not on all three of the lists. So 12 can't be the greatest common factor. 9 has a similar issue. It's not on this one, but it is on these two. But it's got to be on all three of the lists to be the greatest common factor. The first number that's on all three of the lists is 6 here. And so that's going to be our greatest common factor because it's the biggest number on all three of the lists. So the greatest common factor of 12, 36, and 54 is 6. And another way to say this is it's the biggest number that it can divide out of all three, 12 and 36 and 54. Okay, so now they're going to have us find the greatest common factor using that other method that I mentioned. Now, even though I said earlier that usually comes out best with bigger numbers, it doesn't necessarily have to be done with just bigger numbers. You can really use it with any number. So what they're going to have us do first here is they're going to have us write the prime factorization of each number. So we're finding the prime factorization of 40 and 56. Now maybe you've forgotten, so let's go back and refresh our memory here. And when we're doing prime factorization, what we're doing most often is we're creating factor trees. And factor trees are simply a branching diagram that finishes off a branch when you've reached a prime number. And that branching diagram is composed of factors of the given number. And as you go down to subsequent levels, the factors that you list are the factors of the number directly above it. So let's go through that process once. You already know the answer for the prime factorization because that's on the screen, but that doesn't show us how it's done. Okay, so we've got 40 and we've got 56. So I'm going to make my branching diagram here. And when I start off here, I'm looking for two numbers that multiply together to make a given number. So in this case, two numbers that multiply together to make 40 in this case. So I'm going to pick 4 and 10. Now, I get to stop when I have all prime numbers. Well, neither 4 nor 10 is a prime number. Now, maybe you're saying, okay, what's a prime number? Prime number is a number that's divisible only by 1 in itself. Like 3. The only way to make 3 is 1 times 3. 5. The only way to make 5 is 1 times 5. Those are prime numbers. 6, on the other hand, as an example, would be what they call a composite number because while 1 times 6 makes 6, 2 times 3 also makes 6. Okay? Well, 4 and 10 both fit in that world of composite, so we're going to keep breaking them down. So let's go to the 4. 4 is going to get broken down as 2 and 2. And we're going to stop there because 2 is a prime number. And so this whole left side of the tree has been primed out with 2 and 2. Okay, so we'll go over to the right side of the tree with 10. Well, we can break down 10 any way we want, but let's go with 2 and 5 because those are both prime numbers. And since I've primed out now the right side, the whole tree has been primed out, means we have our prime factorization. Notice that the numbers I have circled here are the same as what's written on the screen, just with times signs between them. That's what prime factorization is here. It's a giant multiplication problem written with all prime numbers. Okay, so quickly we'll break down 56. 56, 8 and 7 is probably one of the fastest way home. 7 is prime, but 8 is not. 8 is going to get broken down as 4 and 2. 2 is prime, but 4 is not. And we know from over here, 4 is going to break down as 2 and 2. Now, the question that might be coming up is, now that we have an answer there, well, what if I didn't choose 8 and 7? Well, what if you didn't choose 8 and 7? What if you had chosen 2 and 28 instead? Well, if you've chosen 2 and 28, 28 breaks down as 14 and 2, and 14 breaks down as 2 and 7. So even if you choose different numbers, the end result still ends up being the same there, 2, 2, 2, and 7. And that's true for any given number. No matter which way you start, when you get to all the primes, that part is the same. Okay, so let's jump back to the question now because we've done the prime factorization, but that's not the answer. That's just how we're going to get to the answer. Okay, what you want to do is circle the pairs. So you've got a pair of 2's and another pair of 2's and another pair of 2's. Okay, at this point then, what you want to do is pick a row. Doesn't matter which row, just pick a row. Pick the top row, pick the bottom row, doesn't matter. I'm going to pick the top row. What you're going to do is multiply together what you circled in that row. And that's going to be your greatest common factor. So I have 2, 2, and 2 circled. So my greatest common factor is 2 times 2 times 2. 2 times 2 is 4 times 2 is 8. And that's my answer. You'll see here, right here, they're doing the 2 times 2 times 2 that we just did, and there's our answer matching 8. Of course, you're saying, well, why did I have to pick a row? They're the same. Absolutely they're the same, but you still have to pick a row to come up with that answer. So the greatest common factor of 40 and 56 is 8. Now, same technique here, but bigger numbers and more numbers. Now, looking at this one, the first number there being 252, listing the factors of 252 is probably not something you really want to spend a lot of time on. And that's why they're really going to hear the factor tree technique. So let's practice that again. We won't make the factor trees because we know how to do that. We saw that again in the last problem. That's something you should already know how to do. So for 252, we worked out 2 times 2 times 3 times 3 times 7. For 180, we have 2 times 2 times 3 times 3 times 5. 96 is 2 times 2 times 2 times 2 times 2 times 3. 60 is 2 times 2 times 3 times 5. And again, the whole reason we're doing that is because that's the technique we're going to use to find the greatest common factor. Realize if we were listing factors here, we'd have to list the factors of all 4 of those numbers and then find the biggest number that's on our list. But if we do what we did in the last example, circle our matches. Well, we've got a set of 2's in all the rows. We've got another set of 2's in all the rows. And then, even though they're not in a perfect line, that's not necessary though, we've got a set of 3's in all the rows. Okay, so at this point then, remember again, the directions were pick a row, doesn't matter which one, so let's say I pick the 180 row, and I'm going to multiply together what I've circled in that row. So 2 times 2 is 4, times 3 is 12, which is what they're showing you right here. And remember, that result is your greatest common factor. So the biggest number I can take out of 252, 180, 96, and 60, all 4 of them, is 12. The greatest common factor is 12.